Alright, so now we're going to do Lab 7-4. This is the quantitative analysis of aspirin by spectrophotometry lab. The scenario is that there was a gentleman, while working quietly at his desk, N. Ron Lee, an executive of a multinational energy company, was stricken with what appeared to be a severe allergic reaction. His throat swelled to such an extent that he could hardly breathe. Rapid and effective response to a 911 call saved his life. Both the paramedics and the police wondered what might have brought on such a sudden attack. A bottle of Tylenol was found on Mr. Lee's desk. It was well known that he suffered from asthma, bouts of sinusitis, and lately tension headaches. There were several caplets from the Tylenol bottle that had been submitted to your lab for analysis with the thought that perhaps they were not Tylenol, but that someone had substituted in aspirin or ibuprofen product, hoping to cause a severe allergic reaction. So these are the standards. This is what we're going to use to color the solution so that it can be seen by the spectrophotometer. This is iron chloride. We have a 0 parts per million aspirin solution, so there's no aspirin. Then we have a 20 parts per million, 40 parts per million, 60 parts per million, 80 parts per million, 100 parts per million, and then in a little while we'll do our unknown, which is unknown B in this case. So what I did was I put 5 milliliters of all the known solutions into the cups in front. I then added 5 milliliters of the iron chloride to each of them to give them a color so that the spectrophotometer will see it. And then I poured that solution into these little cuvettes, and those cuvettes are going to go into the spectrophotometer to measure how much aspirin is in the known solutions. And then we will, in a little bit, add iron chloride to the unknown, and we'll put it into the colorimeter. We'll get a number, and then you will be able to graph all of this data to figure out how much percent, if any, is in the unknown B. All right, so this is the actual colorimeter here. It's got a little part that opens up. You put the cuvettes in here, and then you close it, and then the CBL with the calculator will read it. So there will be this sheet that I made up to kind of go with this lab. It's a little bit modified from the textbook just a tad to fit this new equipment, that gives you the directions that I'm about to follow. But on the back it also gives you how to do a line of best fit, because you use a line of best fit to be able to calculate how much of the unknown is in your solution. All right, so we're going to start back over here. I've already turned this on, and I set the colorimeter to 430 nanometers, so right there. I've already clicked apps and the data mate, and it did find the absorbance. You can see that up there. And we are going to then do number 1 for setup. I'm going to press the number 1. And we're going to put in our 0 solution. But to do that, I also have to use a wipe and wipe the sides of the cuvette really well. And then we're going to put the cuvette into the cylinder with the sides that wiped down. This is done like this. Hold the cuvette, make sure we did that, press 3 to 0, so I'm going to press 3 on the calculator, and then it tells me to pick a channel, and number 1 is absorbent, so I'm going to put channel 1. I'm going to let it read for a few seconds, and then it tells me to press enter to 0 it, so I'm going to press enter, and we'll see if it will 0. All right, let's give it a try again. Let's try one more time with 1 for setup. Sometimes this machine's a little finicky, so we got to get it going. So we're going to 3 for 0. Select channel 1. Press enter to zero it, so hopefully it'll zero correctly. All right, and it did. So you can see that the absorbance is 0.002, so that's reading pretty close to zero. All right. So now what we're going to do is we're going to remove the 0 from there, and we're going to do the 20. So again, sorry if it gets a little bumpy from time to time, but I want you to be able to see I'm wiping off the cuvette, putting the cuvette into the colorimeter, closing it, and then we're going to come over here and you're going to have your number. So it looks like it's reading at about 0.049. All right, 0.049. I guess maybe I can try to write that down somewhere. All right, so 0.049. Is the 17th. All right, so now I'm going to do the 40 the same way. We're going to take the 20 out of the colorimeter. We're going to put the 40 in, wipe it down really good, put it into the colorimeter, close the case, and then we're going to read that next number. Give it a second to settle. All right, so 0.072. All right. All right, so 0.072. All right, so now we're going to take that one out, and we're going to put in the 60 parts per million. So that was 40. This is 60. That into the colorimeter, close it. And then we're going to read that number, 0.079, 0.079. All right, let me write that down, 0.079. All right, going to remove the 60. And we're going to do the 80 parts per million, put it into the colorimeter, and we're going to let it read. And then we're going to read the number as 0.087, 0.087. Write it down. All right, and then we're going to do 100. So that's this one here. Wipe it down, put it in the colorimeter. All right. And then we're going to do 0.093, 0.093. All right, now the last thing we have to do is we're going to do our unknown. So I'm going to pull that out. I'm going to add iron chloride to our unknown sample, and it takes 5 milliliters. So 2 of those equals 5 milliliters. All right, you will see that it changed it from clear to a color. So at this point, you should make your hypothesis. I'm going to then add it into the cuvette. Hold on. Sorry. So I'm going to pour that into the cuvette. You fill it up pretty well, and then you add the top to it. All right. Wipe that off, but I'm going to set it up so you get a chance to compare it to the others real quick. All right, so here you You have your ranges 0, 20, 40, 60, 80, 100, and your unknown. Now your unknown is not going to be any of those exact numbers. It's going to be somewhere in between somewhere. And your job is to do a line of best fit graph so that you can then plot B and figure out exactly how much is in there. So now what we're going to do is we're going to go ahead and add this, and I've already wiped it off, into the cuvette. We're going to close that off, and then we're going to let it register. And once it's registered, kind of settles, I think it's pretty close. Looks like 0.083, 0.085, somewhere in there. Write that number down. You can then, now you have to graph your 0 through 100 using a chart that looks like this: concentration on the bottom, absorbance on the side. Your units for concentration is going to be in milliliters, but parts per million actually is what I did. So this is just an example that was on the chart, but we did parts per million for concentration. Your absorbance is a number. There is no unit, but you do need to title your graph. Once you plot your dots, it won't be perfect. You're going to then make a line of best fit, and it tells you how to do that, but if you're not sure, I'm sure you can look online. Once you make your line of best fit, then you're going to take your absorbance, and wherever it fell, you're going to follow it over to the graph, and then you're going to read down. So you're going to make a dotted line over and a dotted line down, and that will tell you how much parts per million your unknown sample B is, and that's going to be your final thing. And then you have to tell us whether there was enough aspirin in the sample to cause an allergic reaction. All right, that finishes Lab 7-4.